To the naked eye, a pathology lab looks spotless, but a UV light sweep reveals what's actually there: patches of hidden microbial residue glowing on a seemingly pristine stainless steel benchtop. Handling pathogens like MRSA, hepatitis B, or tuberculosis triggers strict legal obligations under Australia's Work Health and Safety Regulation 2017. NATA auditors use ATP bioluminescent swabbing to verify compliance. If a surface swab records more than 100 relative light units of cellular energy, that facility fails the audit on the spot. Many labs fail these inspections because they treat biohazards with basic janitorial habits. They rely on standard wiping rather than the scientific precision required to neutralize a medical-grade threat. Achieving true compliance requires reverse engineering the cleaning process from the auditor's perspective, treating every wipe and spray as a controlled laboratory experiment. This diagram shows the mandatory 3-stage protocol. First, decontaminate neutralizes hazards with specific chemicals before any wiping. Next, clean uses detergent to physically remove organic biofilm. Finally, disinfect relies on contact time, the strict duration a chemical must remain wet to disrupt microbial cell membranes. If sodium hypochlorite evaporates before its 10-minute window closes, the disinfection fails. The surface looks dry, but pathogens remain viable and highly infectious. Skipping any stage or rushing the clock guarantees pathogen survival, leading directly to accreditation failure. A protocol that kills a pathogen while destroying the benchtop beneath it is an operational failure. Staff must match their chemical choice to the specific resistance of the lab's physical materials. This matrix highlights those chemical tolerances. Epoxy resin handles high-concentration bleach, but that same chemical will aggressively corrode stainless steel, which requires isopropyl alcohol or Trigene instead. These material choices are critical when maintaining the Class II biosafety cabinet, the primary barrier protecting staff from aerosolized organisms. These cabinets require 70. Once a spill is contained, the resulting materials are governed by the strict segregation rules of AS/NZS 3816. This diagram shows the 3 primary hazard categories. Yellow handles infectious biohazards like swabs and tissue. Red is for cytotoxic chemotherapy waste, and purple is reserved specifically for cytotoxic sharps. Dropping a standard infectious swab into a red cytotoxic bin triggers severe EPA surcharges and audit corrective actions for inadequate training. Regulators judge a laboratory's integrity by the calculated segregation and response recorded the moment a hazard event occurs. All physical cleaning science is secondary to the auditor's ultimate rule. If a procedure is not documented, it legally did not happen. A physically flawless lab still faces corrective action if it can't produce a comprehensive paper trail like this digital log, documenting every contact time, chemical batch, and fumigation certificate. This administrative tracking must also include verifiable staff competency registers and hazard recognition training records. Effective medical-grade disinfection requires the merger of precise chemical application and relentless administrative oversight. Partnering with specialized compliance experts transforms a laboratory from a space that looks clean to one that is definitively secure, protecting diagnostic accuracy, staff safety, and NATA accreditation.